Hi, welcome back. Before the air break, we were looking at using compound angles and double angles to solve 3D problems. Let's continue with another example. Okay, in this diagram, AB is the height of a vertical tower. C and D are 2 points in the same horizontal plane as the foot of the tower B. From point C, the angle of elevation to the top of the tower is X. BCD is equal to Y, and BD is equal to K. And they want us to prove something about AB, that AB is equal to K tan of X times cos of Y minus root 3 sine of Y. Now that looks pretty complicated, but let's break it down and see what is it that they're actually looking for. So let's go back to our diagrams. This diagram is a bit simple in terms of there's only two triangles, actually three triangles, but probably two that we're going to work with. So we have this right angle triangle, ABC, which is right angled at B, but we only have one bit of information. We only have this angle X. That's all we have, which means as it stands, we cannot solve that triangle. So they're looking for AB, we're looking for AB, but we can't do anything in that triangle till we found something else. So there's a good chance we need to find BC first. Once we find BC, then to find AB is pretty easy because BC is the adjacent side and that's the opposite side, because then we could use tangent in that triangle. So we need to find BC first. BC belongs to this green triangle here. And so far we've got this angle, this side, we have the angle across it, okay? We have this angle here, and that's all we have. So we do have three things in that triangle, which means we probably can solve it, but we've got to just make sure that we use the correct rule. So obviously, we've got one pair of matching angles inside, which means we're probably going to use the sine rule. But the problem with using the sine rule to find BC is we do not have currently the angle across it. So our first strategy to see if we can find the angle across it, and of course we can, because we know this angle is 150 and we know this angle is y, so we can definitely write an expression for D. D will be 180 minus those two angles. So once we have that, we can probably find BC, and once we found BC, we can then find AB. So that's our strategy. Let's go and implement that. Okay, in triangle ABC, we said tan of X is equal to AB over BC. So rearranging that, AB is equal to BC times tan of X. Okay, and then we're now going to find our angles like we said. So D will equal to this angle here, will equal to 180 minus 150, and we have that Y. So basically, angle D is going to equal to 180 minus 50, which will give us 30, 30 minus Y. So now we know that this angle is 30 degrees minus Y. Okay, so now we're going to use sine rule because we have that full pair and we want to find BC. Okay, so we're going to use the sine rule and we're going to begin with BC because that's what we've got to find. Okay, so we're going to have BC in the numerator. So BC and the sine across it, which is D, this angle here that we've just found, we're going to substitute it in just now. And the other full pair that we have is BD, this side here, and the angle across it. So BD over sine of 150. Okay, and then D was 30 minus Y, and BD was K, so we substitute those two in. Now we're going to just make BC the subject of the formula. Okay, so BC, the subject of the formula, by just multiplying through by 30 minus Y, so it becomes K sine 30 minus Y over sine of 150. Now, can you see where the metric work comes in, where the compound angles come in? Because now we want to simplify this. But now we have sine of 30 minus Y. We don't know what to do with it. We're a bit lost. So we're going to use, this reminds us of our compound formula of sine of alpha minus beta. So we're going to split that up. And we're going to split that up in a second. But while we're going to split that up, we also have to realize that this bottom angle here, So our first thing is we're going to split that up in the next step. But also this angle here is not an acute angle, so we're going to make it an acute angle. And remember, 150 is 180 minus 30 degrees. Okay. If you were not using the calculator, you could have just found the sine of, if you were using the calculator, you could have just found the sine of 150 at this point. If the question asks you not to use the calculator, then you'll have to proceed as we're going. So you'd make it an acute angle first. Okay, then we're going to use this formula to split the 30 minus y up. So sine of alpha minus beta, sine alpha cos beta, cos alpha sine beta. So let's do that. So in other words, it's going to be sine 30 minus y. So it will be sine of 30 degrees cos of y times cos of 30 degrees sine of y. That's just substituting this into that formula there. Okay, now at this point, you can see we've got all sines of 30s, cos of 30s, and if you are allowed to use a calculator, you can go ahead and use a calculator for sine of 30. If the question says without a calculator, then you will have to use special angles. Okay, so that's the expression we had in the previous slide. Now remember, if you're looking for sine of 30, then either you can use your calculator, if they say you can use your calculator, if they say you're not allowed to use your calculator, and then you can use special angles to find it. And remember, here's our special angles triangle, so we're going to use these two triangles here on the side to solve it. So sine of 30 is opposite, sorry about that, sine of 30 is opposite over hypotenuse, so it's going to be 1 over 2. Cos of 30 is adjacent of hypotenuse, so it's going to be root 3 over your hypotenuse, which is 2. We're using that triangle. And sine of 30, again, is going to be a half. So for the denominator, we've got a half again. Okay, now once we reach this, we've done all the trigonometry. Now there's just algebra to clean up. Okay, so you can see on top you've got 2 as your common denominator. So you're going to common denominator that as soon as you can. So remember, 2 is your common denominator. So in other words, on top you're going to end up with cos y over 2 minus root 3 sine y over 2. So this piece here came from your numerator. And remember, because we were dividing by a half, and we can divide by a half as long as we invert and multiply by 2 over 1. So we've kind of moved a bit faster through the algebra, but that should be easier. So let me just repeat that again. In the numerator here, we just found 2 as a common denominator. So we got cos of y minus root 3 sine of y as our numerator. And then this half, we inverted it and multiplied, because a divide by half becomes times 2 over 1. Now we're just going to multiply all the numerators out and see what cancels. And if you notice already, you'll notice that this 2 and this 2 will cancel out with each other. And all we're left with is k times cos y minus root 3 sine y. So that's what we left for BC. So BC is equal to k cos y minus root 3 sine of y. Now remember, what were we trying to prove? We were trying to find AB. But remember, before we find AB, we needed to find this side. And that's what we found now. So we found an expression for BC, and we got to go plonk it back into that original equation we started off with. And the original equation we started off with was, that's just where we were. So we had BC was k cos y minus 3 sine y. But remember, we started off with AB was equal to BC tan x when we just started that using this triangle, because we said tan of x was equal to opposite over adjacent. We did that already. Now I'm going to take this expression for BC and substitute it in here. And let's see what happens. We ended up with k times cos y minus root 3 sine 2 times tan of x. And if you look at what they asked us to prove, it's exactly the same thing, except that the tan of x is in front. So just rearranging this, I'm going to end up with k tan x. Let me just get rid of this. K tan x times cos of y minus root 3 sine of x. And that's exactly what they wanted us to what they needed us to prove. So remember, when you're proving these 3D trigonometry problems, break them up into individual triangles, and then look at each triangle to see if you have enough information to solve that triangle. If you do, then you can work with it. If not, you may have to use an adjacent triangle to try and find values to help you solve the original triangle.